the omnidirectional ball tracking robot. I chose this robot because it integrates two fields of STEM, robotics and AI, which I'm really interested in, and it just seemed really challenging and cool. So this project tracks and follows this red ball using the Python libraries OpenCV and PyCamera 2. It uses a Raspberry Pi microprocessor, which holds all the data and code, one camera, and two motor drivers, or it's an H-bridge, which sends signals to the motors, which the motors can actually understand. So I'll be showing you three demos. The first demo is the actual software part of the project. This is the code which tracks and follows the ball. So here, as you can see, while the camera is booting up, it will bound the, it'll, let me make the window bigger. It'll bound the red ball in a blue circle. And how I do this is I define a color range within the code. And when the camera finds the largest object made of pixels within this color range, it'll bound that in a blue circle. As you can see, it also displays the distance from the camera to the ball. This is one of my modifications, and this is something that many modern day autonomous cars do. The next part of my project is the movement. And for the movement, I use these mechanism wheels for omnidirectional movement. This means that it can strafe or move side to side like this. And how it works is if you move the diagonal motors in the same direction and adjacent motors in the opposite direction, you'll achieve this kind of movement. So as you can see, it'll strafe back and forth. This wire wasn't connected, it'll work properly, but and there. And then with some manipulation of the speed, it can move diagonally as well. Now, the hardest part was integrating these two pieces of code for the final result, which I'll be showing you here on the ground. Wait. There we go. Okay, so as it connects, there you go. Here's a robot. And while it can't find the ball, it'll pivot until it finds the ball. And once the ball is in the frame, it'll follow using its strafing movement until it stops in front of the ball.
That's huge.
Wait, so through here, it'll pivot, and then it'll follow the ball. And then another thing I did is using ultrasonic sensors, these things here. It'll actually back up from obstacles, as you can see here, which are not the red ball. And then here, one more time, it'll track. And follow the red ball. Thank you. So most of the challenges I had with this project were on the software side. First came the actual writing of the code for the ball tracking. I had to learn a lot of Python, and especially these libraries, OpenCV and PyCamera 2, which I was talking about, which enabled me to work with the camera. These are newer libraries, especially PyCamera 2, and so using any open source code was out of the question. So I had to read the manual and learn each function separately, which took a long time. The next part that was hard was integrating the two pieces of code, which I demoed before, the movement and the software. Integrating two pieces of code is something which I learned to be extremely hard. I had to move, add, subtract, organize, and reorder all this code. The final problem I had was with the circuit. So with these new Omni wheels, I had to add a lot more wires, and I was pulling too much current, or there were too many things connected to my Raspberry Pi, which was causing it to crash or shut down. One way I did to solve this problem was I designed a PCB, or a printed circuit board. This is an electronic assembly which replaces wires and a breadboard, which I had used originally, that creates connections with copper. I use this PCB for these electronic sensors as per suggested by my mentor, Landon. One thing I'd like to do to make this project better is that the robot follows and tracks only circular objects, For example, this is a big problem I had in testing. It would follow all kinds of red objects. For example, that red waffle iron over there. It would follow all kinds of things, and that was just messing with the performance of the robot. My overall experience at BlueStem Engineering was extremely fun. I learned a lot about topics in STEM, and I had a lot of help from my mentors, and I really appreciate that. Thank you. Any questions? Yeah, Jack?
I'm curious, you only showed us one side of that PCB. I can't help but wonder what's on the other side.
Okay, yes, on the side, it's a little embarrassing picture here. You good, Chad? Yeah?
Arman, I think you showed one feature where the car can actually move
Yes.
sideways, right? Do you think that can be a real world application that you can actually park a car in a very nice place?
So these are Mechna wheels. As you can see, they have these little wheels on the side. These are actually not very reliable on actual cars. It has been something that's been tested before, but it's not really helpful. I know something that has been tested before and used on actual streets is turning normal wheels 90 degrees like this and moving it like that. That is something I could have also pursued, but I decided to go with this method.
Good stuff.
Thank you.